I need water. Well, I will get that. You know what I should do? I should run these problems back and do them in like a teachable moment. Not moment, but like instead of just watching me work through it, I could be like, here's how to solve this problem and then like explain it. But then I don't know. I'm more concerned about recognizing the pattern when I see it. Does that make sense? I don't want to memorize the solution to this particular problem. I want to say like, oh, we have to keep track of certain things when we're trying to match words, so we have to probably use a frequency dictionary. Right? But I don't want to just jump to that right away. I want to walk through the problem myself and be able to arrive at a solution. So I think just looking at it's good. Looking at problems is good. Looking at different solutions is good. And just doing that there. I've had permanent throat phlegm for like 6 months. I don't know if it's America. I've had permanent. I don't know if it's America. I don't know if it's diet. I don't know if it's my air quality. I don't know. But it kind of sucks. Anyway, clap it up. We've accomplished something. We finished 2-pointer. We finished sliding window. I'll even show it so we can. We've covered every single problem and the solutions to those problems and written it up on this sliding window Jupyter notebook with running code and tests, which is great. Just freaking amazing. I can run the entire thing and you can see all the tests passing and the testing framework we initialized. Pretty cool too. I have all that on camera. But yeah, I do want to go back and understand these problems again and try to pull out the nuggets that matter. So, I mean, moving forward, we're looking at this initial for loop. We're looking at, management of this dictionary, or what else did we do in the past? We did management of, in or not in account, more of the count, or we're doing a sum, where we're basically keeping track of that. Okay, yeah. I mean, this is actually not too complicated. The hardest stuff and the most interesting stuff comes with the character frequency dictionaries. And then what we, given that window, what are we calculating based on that stuff? So definitely fun to go back and look. I'm probably going to go back through my, I'm going to go back through my videos that I recorded, my archives, and just hear myself talk out loud about it. See if I can pull anything from that. But anyway, I have 30 minutes to do another problem. Ideally, I'll be able to get through these 2 problems before my 9:30 meeting. It's currently 8:30. So if I read this, if I read this and what's it called? Get through these problems, I should be able to. It's gonna be a good start because I have. How many do we have total? If I get through these 2, I'll have 1, 2, 3, 4, 5. What is this? Oops. I get through these 2 easy problems. I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 problems total. I'll get through 2 of them already. That'll leave 9 left. So actually 11 total. And I have to get through fast and slow by Friday. So if I don't complete all these problems today with 2-pointer, they'll bleed into tomorrow, and then I have to start fast and slow tomorrow and finish it Friday. The intent is that on Saturday I'm going to review these problems. I'm going to go back through the ones that were really difficult, make sure I understand why we're doing that. I'm trying to understand the pattern at a deeper level and be able to then derive from the conditions, of the tests and the objectives of the problem, these two things come together to form a solution that solves these problems. So that's kind of the point of the Saturday review. So I'll record that session as well. Jasmine comes back Saturday morning. I'm not sure how early, but the goal is to at least be able to, speed through that. Anyway, on to 2-pointer. And probably deal with sorted arrays, linked lists. And you find a set of elements that fulfill certain constraints. The 2-pointer approach becomes quite useful. A set of elements could be a pair, a triplet, or even a subarray. For example, take a look at the following problem. Given an array of sorted numbers at a target sum, find a pair in the array whose sum is equal to the given target. Isn't that 2-sum? So we could use 2 pointers for 2-sum. I said find a pair, so 2. Okay. 2-sum is fun because it's a classic computer science problem, in that it's the one that everyone gets but never knows how to solve, but it's the easiest one to solve once you have the solution. Which can be said for all DSA problems, but to solve this problem, we consider each element one by one by the first pointer, as in this illustration down here. Then we follow through, and we iterate through the remaining elements with the second pointer. I'm nesting them for nesting purposes. So this one starts here, go down the list, cool. Start here, go down the list, cool. Start here. I'm moving the second one because you're not going to look at the rest. You've already seen those numbers before, so I'm going to keep moving. The complexity is O of n squared, where n is the number of elements in the input array. Actually, it's n squared, so it'll actually be each time you look down, you'll see the same one. Given the input array is sorted, an efficient way to turn would be to start with one pointer at the beginning and the pointer at the end. Every step we'll see if the numbers pointed by the 2 pointers and add up to the target sum. If they do not, we'll do one thing. If the two numbers pointed by the 2 pointers is greater than the target sum, that means we need to pair with a smaller sum. So to try more pairs, we will decrement the end pointer. Since it's in an ascending list, right, it makes sense to take a lesser number, if that makes sense. If the sum is smaller, then we'll take a greater number. We'll move the start pointer up. So complexity is O of n. Following chapters will cover 2 pointers. Solve problems. Excited. Pair target with sum. Easy. Okay. And I should probably create a grader notebook that just imports everything for me, but I'm not going to do that. Problem statement. Good, fun. Now this 2-sum using 2-pointer, can it be done? This is a pair with target sum. It's not 2-sum. 2-sum is there are 2 numbers and only one pair of 2 numbers that add up to a sum. Target sum, there could be multiple pairs in here, but whatever. Right? There could be. I don't know if is that constraint. I don't think so. I think I've already started this one, right? So I've already solved this problem. I'll reset, just rethink through it anyway. I'm not starting the timer until I feel like a problem actually requires a timer. Because with the timer starting, it's gonna just it'll confine me to only solving 2 problems here. If I can get through all the easy ones before my meeting, rock on. If not, my problem is a 2-sub B. A 2-sub B. All right. This look good? Oh, it does not. What if I did that? Ooh, I like that. All right. Let me first of all grab some imports, because duh. Can I copy an entire cell? can copy a cell. No way. Oh, yeah, C to copy and just V to paste. No. That's crazy to me. Just crazy to me. That'll be the first thing we do. Also add a, what's it called? 2 pointer. So 2 pointer, basically I'll sum up the so if we were to sum up 2 pointer real quick, what would I say? I would say something like 2 pointer is an approach to piece for finding, well, a set of elements that meet the given constraints. Now, the funny thing about this is that the same can be said for sliding window, but it's another method for finding that. Now, why would you use 2 pointer over a sliding window or sliding window over 2 pointer? Well, if I run this real quick, I realize you can just run this. Or it's like something like this. It runs it as a shell command. You just do bang python.m, so that's pretty cool. I like that. We import pytest and ipytest. Okay. Back to where I was. It's to meet the given constraints. And the question is, when do we use 2 pointer over, right? Because with the sliding window, that also could be said to use mostly nested loops. And the same could be said for 2 pointer. So again, when is it better to use 2 pointer over, and maybe we'll discover that as we do problems. But I mean, given the problems I see just on the list, you know, some close to target, some to 0, Dutch national flag problem, subarrays with product less than the target. So these seem to be solving similar problems. I'm a little bit worried about the overlap. I think there's definitely overlap. I think sliding window is great for sliding window technique is great for, like, in my opinion, the harder problems are like contiguous, like subarrays or substrings, and I think you could do it with 2 pointer. I think it just be a different approach. So I'm not sure. Not really sure. But I guess maybe we'll come up with a better answer as we do problems. Anyway, let's look at pair with target sum. So as described in the initial introduction, we have this list of integers sorted. The key is that they're sorted, which is why we can even do 2 pointer. If it wasn't sorted, if you can't sort it, you might have to use sliding window. Yeah, or for example, like, you can't use binary search, or binary search is ineffective on a non-sorted array as well. So it's important to have. Let me up the heat. Actually, I'm a little chilly. I'm finding all kinds of reasons not to do this problem. Okay. So let's say we have an array of integers sorted 2, 3, 4. I'm really just reviewing. I know how to solve this problem already. So the point is to say you have 2 pointers, start and end, and you say that, the point is to say while, well, let me not even get the code. So if we're gonna use 2-pointer, I'm gonna start my loop, checking to see if the sum of these, if our target is 6, is the sum what am I saying? The point is to find 2 numbers that equal the target. And so you'd add, if you're starting with 2 pointers, one at 0 and one at length of the list -1, or index, what is this, 5, 4? 0, 1, 2, 3, 4, right? Index 4, you'd say, okay, index 4, index 0, which is 1, 6 equals 7. That's not the target. And you don't just keep guessing, but you say more so 7 is greater than the target. So we need a smaller number. Now, because we know it's a sorted list, we know that the smaller numbers are on the left from wherever you are in the list. Wherever you are, meaning as long as you're not at index 0. So if you're index 2, there's 1. If you're index 3, there's 2 and 1. If you're index, if you're index 3 or number 4, there's 3, 2, 1, right? That idea. So the point is, okay, 7's too high. So we now change our end pointer. We decrement the end pointer by 1, point to 4. Try again. 1 plus 4 is 5. Too low. So we bump up the pointer, the start pointer, increment by 1. We say 2 and 4 equal to 6. Great. We have the indices in the start and end. Return that. That's the point of 2-sum. But that's not 2-sum, but 2-sum using 2-pointer. There's a 2-sum problem that can use a dictionary, but it's on I think it's in a non-sorted array. Now, would sliding window make sense? No, because, well, actually, no, it wouldn't. It wouldn't make sense because you want specifically 2 numbers. So it's a different approach. There's none of these approaches. Well, actually, no. Actually, this approach solves 2-sum. This approach solves 2-sum, the 2-pointer approach. So I keep forgetting. Problems can be solved with many approaches. Okay, problems can be solved with many approaches. I shouldn't try to box 2-sum into the solution I've solved it before, because this 2-pointer can also do the same thing. So I start and our end. We're going to start with 0 and length of our array, -1. I love type hinting, so, well, I don't know why I'm coding here, by the way. Everything can be done in one file. So find a function, pair with target. I kind of hate this, not gonna lie. With an array of ints and our target, which is an int itself, and we're going to return I'll just say ret, and ret, well, I really should say this, right? That's what I should say. And it returns a list of ints, or if it's not present, it really should return union. Can I say that? I think that's allowed. Or I really should return, okay. I can say returns a list or list of ints. That's valid typing. Anyway, our start and end begin at 0 and length of our array -1. And the point is to, oh, this is always been a list of integers. Got you. That's why it didn't make sense. The point is to say while start less than end. We don't ever want them to overlap. we can't use the same number twice. So for example, we would never want to, let's say for example, let's say we have, so instead of 1, 2, 3, 4, 6, we have 1, 2, 3, no. What did I say here? Yeah, let's say we have 1, 2, 3, 5, 6. If our pointer starts at 1 and 6, 7 too high, we bring it down 1. Oh, 1 and 5, fuck. That was bad. Basically, we don't want to use the same number twice. So even if the only number, if I just take out the 5, right? There's nothing here that adds except for 3. There's nothing else that points to 3. So I try 1 and 6 too high. I try 2 and 6 too high. So I bring that down. So we try 2 and 5 too low. We try to make start and end equal the same thing, and that's not going to work. Okay? So it doesn't exist. So while start less than end, our sum, I would say cur. I use cur a lot, I don't know why. Our current sum is equal to array at start plus array at end. 848, damn. I'm so slow. If current sum, the current sum is too small, what I'm thinking about right now is how to return faster. But I mean, worst case, we look at every single pair that's O of n, so it's not that bad. So we'll just say if current sum less than target, we get a higher number. So we're going to bump. So we're going to bump our, what's it called? Bump our startup by 1. I think of the case where target is equal to target. What do we do? I don't know. I got hiccups. Why? Is that 7? I lost track. If current sum right? Then we do our end. That's the idea. And the point is that else it's equals to just, I guess, break. It's valid code, right? No, we're fine. All right, let's find some tests. Yeah, pair with target sum, and it should take in our array, list of ints, our target, which is an int, and our expected, which is a list of ints. And we should add our tests decorator, and I'll take in our array, our target, and our expected, passing our tests. Okay. I should write this code actually. Insert pair. Pass in the array, pass in the target. That's equal expected. Cool. Our tests are what? This array with a target of 6. We expect this to spit out an array containing 1 and 3. And then, yeah, probably watching me code is probably pretty boring, because I don't really talk a lot over my work. Maybe I should, I don't know. 0 and 2. All right, and then run our ipytest.run, run all our tests. It works, yay. Now, if there is no solution, let's just write one where there's no solution in it. 1 and 2 is fine. 11. This should return 0 and 1. Well, yeah. Yeah. Right? I mean, when there's no solution, we're assuming there's a solution, right? Yeah, let's run with that solution. Let's run with that. We're assuming that we get this data and there's going to be a solution in the problem. That's okay. I'm okay with that. I'm okay with that assumption. Okay. Complexity analysis. This is, if I could find the markdown. This would be big O of n, as we might visit every number in the list. Space. I could type today. Big O 1, because we don't. Well, yeah, big O 1. I was gonna say we have an array of integers, but it's at most 2, so big O 1 is fine. That's not a true statement, but I'll just say big O 1. I know why. Fuck it. Doesn't really matter. Next. What they do? They said return -1 1. That's the only way to do it. Yeah, if you want to return, like if it didn't find it, I'm assuming that there is a solution. If you want to assume there's not a solution, then you either find it or you don't, type of thing. But then you have to know the inner workings of the code to be able to, like if I was going to use this, I would expect to get back something like -1 -1. To be like, oh, it's not there. Yeah, let's add that in there. Let's just throw that in there now, because start and end. Otherwise, you can return. So we can add a test now that says, you know, that should return -1 -1. Sweet. All right, next problem. Another approach. Whoa. Binary search. Wait, what? How? Okay. Storage. They're enumerating target sum, minus num, in nums. Otherwise, add it. So that's the other approach that I think people are used to, using a dictionary to track numbers and their indices. Then basically saying like, so it uses a for loop instead of like the while loop and the 2-pointer. It's definitely, I wouldn't say shorter, too much shorter, but definitely visually appealing. So basically what you do is you say, okay, I'm looking through this list. I'm seeing, numbers. Let me use my whiteboard here. What you're gonna do is you're gonna say 2, 3, what? 2, 3, 4, is this 6? Yeah. Target is 6. So what we say is we say, okay, we're going to iterate over the list one at a time. Okay? Start with 1. If 6, target sum, minus 1, our current number, is in our frequency, is in our, not frequency, but in our numbers dictionary, then we're going to return the index of the complement to that problem and the index we're currently at. So what we're looking for here is we're basically saying, is 6 minus 1 or 5 in our, is there an index in this array with 5 already? That's the point. If there is, give me that index, right? And give me the index of the number we're currently at. That's basically the point. So we'd store, so if it's not in there, we'd store it. We'd say, okay, cool. The dictionary would update it, say 1, index 0. Is 6 minus 2, 4 already in there? No. So we'd add 2, index 1. We'd say, okay, is 3 minus 6 already present? No. So 3, index 2. We'd say 4 minus 6 is 2. Is that present? Yes. So give me the 1 and give me the 3. That's basically the point. Yeah. Cool. That's the one that people normally use. I don't know why it's so common. 2-pointer is great and applies to more. This is more of a, I don't want to say hacky, but it's a more clever solution using one for loop versus like a while loop that can go on for, not for, but you get the point. It's a while loop. People don't like while loops. Then space. 2-pointer is better. Okay, so 2-pointer has better space complexity. Yeah. Sure. Remove duplicates. Okay. It's an easy problem. Given an array of sorted numbers, remove all duplicate number instances from it in place such that each element appears only once. The relative order of the elements should be kept the same, and you should not use any extra space so that the solution can have space of 1. So we have to use 2-pointer. Move all the unique elements at the beginning of the array. Move all the unique elements at the beginning of the array to the beginning of the array. After moving, return the length of the subarray that has no duplicate in it. Wow, this is an easy problem. What? Well, this is a little bit complex. Are we supposed to use 2-pointer for this? Okay. I'm a little bit nervous. I don't know. Remove. Returns what? Returns the length of the subarray that's unique. We don't actually have to remove them. We just need to make sure our length gets updated anyway. Okay, return something. If I say false, check me. No. Weird. Yeah. Define test. See, this one seems kind of not hard, but I might take some thinking. I might actually do a timer here. Actually, it's already 9:01. So a timer is probably needed. An array and expected output, test pass in. I'll say, I'm even typing my tests. Make sure I don't miss anything. Whoa. Ugh. All right, let's take a look. Why did it fail? This is not important. But running clean does clean it, I guess. Huh. Strange. Very, very strange. Okay, so we have a list. We can't use any extra space to keep track of what we've already seen. Right? We have this list of ints. Let's see. 2, 3, 3, 3, 6, 9, 9. The resulting output should be 4, which is the length of the unique, right? Now, does that have to have O of N runtime? Potentially. So the idea is to get to something that looks like this. 2, 3, 6, 9, and return 4. How do I do that? Well, I'd say, is there a 2 anywhere else in the list? No. Is there a 3 anywhere else in the list? Yes. What? Then we look at things non-3 and then do a swap. And then bump that over there. Is that right? And then we move to 6. And we say, are there any other 6s? No. Then we move to... So what's crazy is that we just swapped this 6 and this 3. So now we have a 6 here and a 3. We swapped it. That kind of poses a problem, right? So I don't think swaps are going to work. But the point is to, I mean, we can remove from a list, right? Or am I insane? There's not really a remove function. I mean, there is. Well, it removes the first. Oh shit. Yeah, we don't want to remove. We want to remove every other instance from the list. Not just take out all the 9s, but take out. Does it? Looks like rabbit, dog, dog. So there's 3 dogs. It takes out 1 dog. Huh. Okay. Huh. So in the last problem, right, we had this idea of finding the sum, right? And we can't use any extra space, so we have to, in place, remove elements from a list. Can I just delete? Is that a thing? So there is a remove function. There is a pop function. But pop doesn't in place, it's an in place removal. So calling pop might be the thing to do. Okay, so let's try this again. I have 2. I would want another pointer to then move from our start plus 1 and check for any other 2s and pop it if it finds it, right? And then start with the 3, move beyond this and pop any other 3s. Is this sorted by default? I think it is sorted. Okay. But that's in what, log n, not log. Then start from, then it would be 6, 9, 9. Then it would be 9. So that technically, I'm returning the length. I mean, that kind of works, right? So I'd say like with a start pointer. So I'd say like, I mean, we want to loop, modifying the loop. I think we can do that. We can do that. We do that. So for I in range, right, of the array, length of the array, we'll get a current number, which is equal to the array at I. We'll say while, our pointer is what, less. Well, we're modifying the list. We're essentially changing the range. We have to modify this. If we can't do space, we have to do in place, right? I'm not picking the solution. I don't want to look. I want to do this. It's supposed to be an easy problem. Easy sounds, it's still misleading. So if I were to do that, I'd say, okay, while pointer less than that, iterate over if array at pointer equal cur, then we say what? Array dot pop at ptr. Does that make sense? But we're popping from a list while iterating over the list. Our range generates numbers based on a list. So can we do a different method? We could enumerate, but again, modifying a list while it's running has a code smell. You might be trying to access indices that don't really exist anymore. So I'm a little bit, I mean, we could just return a set, but I mean, a set probably does that already. We could just return a set, the length of the set. That would solve the problem. If I was at work, right, I would return the length of. This is what I would do. If I was at work, if I was at an interview, I'd first give the solution. This is the one you want to use. We're working Python code. Don't worry about that. Right? That's what I want to do. Take this. You should see 4. I run this code. Right? Take this. We should see. So I have a solution that works. Okay, now behind the scenes, a set is doing what I'm supposed to be able to do. You can't use a set. Let's say it's a different kind of list. I'm looking at it. So they say next non-duplicate. What do they do? So they have a next non-duplicate thing. They basically say your next non-duplicate points to this, and your iterator points to this. You say, huh. Oh, so you're basically counting unique values. You're not actually modifying the list. What is this? Yeah. So basically, they're saying that the next non-duplicate points to 1 as like an offset. And they say, okay, if they say if the array at next non-duplicate, so if 3 is not equal to 2, because it's sorted, right? This solution is fine, right? But it's not the way they wanted us to solve it. Technically, it's not the right space complexity, and maybe not even the right runtime. I don't know how set does duplication removal, but at work I probably just use that. But the length of a set, at that point you want to use a generator, and then call that iteratively, and count something there. But yeah. So they have a non. So they have a. So it is 2-pointer, right? It's you're looping through the list at I, and my breath stinks. I need to brush my teeth. Yeah, getting up early, fucking bites me in the ass every time. Or charge them. Thank God. My headphones. Thought about work for a minute. And I was like, my headphones are not charged. That's the problem. Okay, they're charged. Yeah. I don't know how to I don't know how to I don't know how to implement what they're asking us to implement. I shouldn't say that out loud, but for some reason, thinking about the problem like this never comes naturally to me. It never comes naturally to me. I don't get it. I don't get it. I don't get it. It never comes naturally. I do not, no matter what I do, I'm sitting here like, I don't even, how would I get to that? How would I think, oh, it's 2-pointers, so we have to use 2-pointers and we're going to force it? Like, if it doesn't lend itself to, I think I need more, I want to say accurate talk through of the problem. I want a more accurate talk through of the problem. The way I talk through it, I messed around. I said, okay, we'll use 2-pointer, right? But they didn't say it had to be O of N. Anyway, come up with a solution and then break it down, right? That's the point. That's the practice here. The practice is not to memorize the pattern of 2-pointer and just apply it to everything, but to say, okay, if it is a 2-pointer problem, well, the way you walk through your tests should tell you how to solve the problem. Okay, it should tell you that you need to iterate, at least look at, you need to look at everything eventually, right? Because you want to remove duplicates, but you're not actually removing duplicates. The term tricked you into thinking you had to modify this list. You ain't gotta do that. You don't do that at all. So all I had to do was literally, they call it remove duplicates, not really. With 2-pointer, you're not really, yeah, you can't modify this. So modifying it was already out of the question. That's why I didn't use that other list. I can't modify a list while you're running through it. Yeah, that's just, these are the breaks. You know what I'm saying? These are the breaks. Can't wait to get my Lian Chin. I'm done with that for now. Next session, we need to talk through the problem with tests and try to apply the actual technique to the problem. The actual technique. Crazy.